Very much, John, for the introduction. So my talk is titled Social Robotics and AI for Assessing Child Mental Wellbeing. But first of all, I just want to say that that's not the only topic my group works on. So my lab, the Affective Intelligence and Robotics Lab in the Department of Computer Science and Technology, undertakes research on multimodal, social, and affective intelligence for AI systems, particularly social robots, embodied agents. And we have a strong focus on machine learning, fairness, explainability, and also applications to well-being. So this area, child mental well-being assessment, is one of the areas we have been working on since 2020 in collaboration with colleagues from the Department of Psychiatry here in Cambridge. And the motivation for this project actually just goes to the fact that mental well-being issues and concerns in general have been increasing over the years. And post-pandemic, I think these numbers have changed and increased as well. And the percentages you see there might be different for adults or children, but overall, there's an agreement by the World Health Organization that we should focus on promotion of mental well-being, prevention of mental issues, and also having efforts to increase access to quality mental health care. And children, as John rightly put, are important because if we actually can flag early on what's happening, and if there are cases that we really need to pay attention to, this will affect the rest of their lives. So early assessment is crucial, but also actually talking to children might be challenging because children see teachers, parents, and even therapists as authority figures, so they might not disclose their true feelings. So there are different challenges in this area. So what we are proposing is social robotics could provide an alternative means, both for assessment, but also intervention. I'll be focusing more on the assessment aspects today. And why social robots? Well, because there are already studies showing that children have very positive attitudes towards social robots. They actually like and engage with them. And if they are the size of a child, so similar to their own size, they perceive them as peers, not just toys. And this, of course, helps with what I mentioned about not seeing them as authority figure and therefore disclosing information and so on. But also social robots are physical and they're in this world, so it helps keep the children in the physical world. And also they're engaging, so you could actually enable them with different personalities, different communication capabilities, multimodal interaction capabilities. You could place them in different environments, not just clinical contexts, but also places like schools or even play areas and so on. So there's a lot of potential social robots can provide in this area. So the vision we started with is this AI-powered robotized assessment. What you see here is one way of representing the procedure for mental well-being assessment of children in the UK. So if you see actually this procedure, what happens is usually the childcare spaces contact the families, and if they provide consent, the children would be interviewed by a lay interviewer using standardized questionnaires, and these will be recorded and saved. And then this will be sent to clinicians so they can actually do diagnosis and access this data. So what we are proposing is the second part. So this middle bit can be potentially undertaken by robots because that would mean that we don't just administer questionnaires, but we can also record their verbal and non-verbal responses, not just what they say, but also how they talk, what sort of expressions they show. All of this can be recorded and analyzed, and initial flagging can be done, and can again, this information be saved and sent to the clinicians. So this is our vision where things would fit with AI and social robotics. So we started with our initial studies back in 2021. And first of all, the question we asked was, can robots be used to assess children's mental well-being? Okay, we have all this vision and so on, but is it actually possible? So what we did was we contacted schools in Cambridgeshire, and then parents gave consent and they volunteered to bring their children over the weekend to our labs. So this sort of continued for over 2.5 months. And we managed to work initially with 28 children between the ages of 8 to 13. So they interacted with the Now robot, that is a child-sized robot. And we also asked both the children and the parents to fill one of the standardized questionnaires before they came to the lab. This is known as the Revised Child Anxiety and Depression Scale, RCAT for short. So both the child and the parent filled this. And once they came to the lab, they did different tasks with the robots. So I'm going to show videos so that you have a sense of how actually this looked like. Just a warning, we don't have videos of actual children due to privacy. This is my postdoctoral researcher at the time, Mika Hospitalis, so she's the one talking with the robot.
Hey, first, I would like to ask you if you could think of some nice thing that happened to you in the last few days. Something that made you smile or happy. Can you please tell me about it?
Yeah, so I'm really happy because my best friend is coming visiting me this afternoon, and we are going to play together. So yeah, I'm really happy about that.
So that was memory recall, and they could talk about happy and sad memories they shared with us. And here are some examples of what they shared in terms of happy memories. So fun activities, accomplishments, experiences with family and friends. And in terms of sad memories, again, experiences at school, fighting with friends, being bullied, fighting with family, and so on. Another task then involved the robot administering questionnaires. And here we see the SMFQ questionnaire.
2 weeks. You have felt miserable or unhappy.
Not true.
And then they also did picture tasks. So certain pictures from the CAT manual, this is a standardized manual, were shown to them. And they were asked to tell what they see in the picture, so to provide a narrative.
What do you think is happening in this picture?
So I think that there is a tiger that is chasing a monkey, and they are in a jungle. Maybe the tiger was just hungry and she wanted to eat the monkey.
So then after we have these responses, with the guidance from our psychiatry colleagues, we divided the participants into 3 clusters, also known as tertiles, and using the total scores computed from this SMFQ during the session with the robot. And we see here in the figure lower, medium, and higher tertile. What it means is lower tertile are the ones that are unlikely to get a diagnosis, so they have high well-being, and higher tertile are the ones that are highly likely to get a diagnosis. So using this tertile categorization, we did further analysis, and I will show you some of the findings. So here you see a ranking of the methods highlighting the differences in the population across well-being clusters. And what you see is actually the ranking goes robotized, self-report, and parent report in terms of this, which one provides or highlights more the differences in the population across well-being clusters. So we see the robotized most is the best one for this purpose. And then we also looked at the generalized anxiety, panic disorder, low mood subscales, and the total score as well. Again, these were significantly higher for the higher tertile group compared to the lower tertile group in the robotized mode. So you can see again the differences here. The blue is the robotized mode for higher tertile. So what we see from both of these is actually if the children are highly likely to get diagnosis, this is really highlighted in the robotized mode much more compared to other modes of administration. Then we also extended this work. We increased the number of children to 41 and also balanced the genders as well. So what we found is that increasing the sample size does not change our findings. So children in the higher tertile show higher values in terms of auditory and vocal features. So we looked at nonverbal behavioral cues as well. And here I'm just showing some examples. So we look at things like facial action units for expressivity, not just these two, AU1 and AU4, but others as well. And also audio features. So these are nonverbal audio features, so how they talk. And we also saw differences there. For instance, children in the higher tertile show more intense and frequent facial expressions, particularly during the sad memory recall. And also we saw differences in terms of gender as well. So girls who are more likely to have mental well-being concerns display more expressive responses than boys. And then we wanted to conduct construct validity analysis. And the reason is actually, are these questionnaires valid to be conducted in these sort of settings? Because originally these questionnaires were not created and validated for a robot, child-robot interaction or novel interaction environments. They were created for standardized traditional ways of doing those questionnaires, like I mentioned earlier. And our analysis actually, via confirmatory principal component analysis, showed that yes, they are valid, but there are some differences. For instance, what we see here is certain items load well, like here item 5 and 8, but some other items don't load as well. And here we see item 2 and 6, and some don't load at all, like item 4 and 11. And then we saw similar cases also for the ARCADS questionnaire. I'm not going to go through all of it, so I'm just showing here 2 items, and you see the differences, one not loading as well. So what this makes us conclude that both of these can reliably be used in child-robot interaction settings like we did for well-being assessment. But we also need to bear in mind that perhaps we might need to do some revision and modify some of these for novel assessment techniques via AI or social robots. Then we extended our work to online and longitudinal interactions. So the goal was actually, do these results still hold if the robot is interacting virtually with children? And this time for our study, we opened it up to children from different countries. So we had children participating from places like Kazakhstan, Tajikistan, Singapore, as well as UK. And they also did 3 sessions actually. So they continued with around 10 days to 15 days of difference between sessions. And again, in total, we had 40 other children. And the procedure was similar in terms of what they did before the study and during the study as well. So again, what we see here is overall, robot-assisted mode of ARCAS administration is highly, again, effective in categorizing the population across well-being clusters. So it's, again, similar finding. What does this mean overall is online longitudinal robot-led initiatives actually can be as effective as physical robots in carrying out well-being assessments for children. And then we also wanted to investigate how we can use AI. So we did various experiments, and I won't be able to cover all of it today, but I wanted to touch upon one related to using foundation models, because this is the trend nowadays and everyone is interested. So this is the latest paper we just had accepted and will be presenting in August at IEEE Roman. So AI assessment of child mental well-being. Here we are focusing on one of the tasks that I mentioned. So this is the child perception test data. So you see here, for instance, these 3 images that the children were shown as a pictorial stimuli, and then they're asked to provide narratives, as you saw also in the video I played. And then we employed a visual language model for the assessment. I know there was criticism regarding LAVA in some of the poster presentations, but we need to remember for children, child data is quite sensitive data, so we can't employ any LLM. So also in our ethics application, we really had to ensure actually even the robotized interactions will not be done with ChatGPT. So they were pre-programmed, and therefore we used open source large language models that can be deployed offline, locally on the computer and so on. So I just want to make sure everybody understands that aspect as well. So this a bit more detail here. I'll quickly try to go through it in case people are not that familiar with prompting. So the way it works is, first we have the VLM prompt by including the CAT procedure. So this is quite specific. I wouldn't be able to go into details. You might need to read a bit about the CAT manual and how these sort of assessments are done. And then we also provided information related to children's demographics, like their gender and age. Then we have the question and answers between the child and the robot in terms of text, and also specific aspect related to the CAT section and the specific item we are evaluating. And in terms of output, again, it's a bit more detailed, so I won't go into detail, but basically, we're interested if it's multiple choice, you know, if VLM is returning the fitting item stated or there is no choice as applicable, and if it's item-based evaluations, it's slightly different. But overall, what we are interested in is comparing these assessments with the psychologist assessments. So what happened was, when children did this task, one of our collaborators from the psychiatry department knows the CAT manual, went through all of their responses and provided actually specific scores and labels. So we had ground truth label in terms of which child would receive an assessment or not. So we are comparing VLM's output to that ground truth. And what we see here is if the children have high well-being, so there are no concerns and possibly won't receive any sort of assessment or flagging, actually the VLM does well. So 82% of the time agrees with the human expert in that sense. But if the children are likely to receive a diagnosis, and this is here shown as assessment, VLM does quite poorly. So it only agrees with the therapist around 13% of the time. And if we include children's demographic data, like their gender and age, this does not change the findings. But interestingly, what we saw is, particularly in terms of false positive rates, we see actually VLM incorrectly assesses girls as positive. So this sort of makes us question, okay, but demographic information did not provide effect. So what's happening here? We hypothesize that this is probably due to the way the girls express themselves when they talk, right? The way they construct the sentences or the way they use certain expressions and so on. So there are differences there. So taken together, my key takeaways for today would be, so first of all, compared to standardized modes of administration like self-report questionnaires or parent report questionnaires, robot-administered questionnaires actually demonstrated a better fit in terms of construct validity. So this suggests actually interacting with the robot for children may facilitate a more coherent and reliable disclosure of symptoms. Then we have to bear in mind, okay, the validity analysis shows we can use and administer these questionnaires via robots, but not every item loaded well. So we need to bear in mind perhaps these need to be revised for novel assessment technologies via AI or social robots, or perhaps we need new scales and new methodologies tailored specifically to those environments. And then we also need to bear in mind we found gender-related differences, both in terms of responses but also nonverbal behaviors. So this really makes us question in a way that typical way of standardized questionnaires do not actually apply to everybody the same way. So we might need to adapt or even personalize the way the assessments are done because one size does not fit all. And finally, as an example I gave here, AI-powered assessment has potential, as we saw, particularly, if you want to just sort of filter out the cases that do not need any concern, it can actually provide this quite quickly and reliably. But of course, we also saw there is some bias there. So this indicates we might need to mitigate this bias and also just bear in mind if you're using AI to always check for these biases if it's present or absent. So what's next for us? So first of all, we will be going to the AI for Good Global Summit in Geneva soon, in July. So we have been invited to present on this research, and we will have a stand there with the robot as well, demoing it. But also, we have a new project called Micro, measuring children's well-being and mental health with social robots. This is funded by Chance, and then we will be focusing on this for 3 years, but particularly also focusing on vulnerable children populations like refugee children, for instance, Ukrainian refugee children in Sweden, as well as children that have language developmental challenges or disorders. And this is our consortium, so we'll be working with Uppsala in Sweden, ETH Zurich in Switzerland, Bielefeld University in Germany, and at the University of Cambridge, we actually will be collaborating with Faculty of Education. Professor Jenny Gibson is here, and again, the psychiatry department as well. So we're really excited to be able to apply this for different children's population groups. And with that, I would like to acknowledge all the people that have been working on this project now for 5 years, particularly Nida as a PhD student, and this was funded by W.D. Armstrong Fund that supports medicine and engineering research, and as well as various postdocs and our collaborators in the Department of Psychiatry, as well as CHIA for the funding. And I will just leave you with our long-term vision. I won't be going through it, but I'll just leave the slide up there. And this concludes my talk. Thank you very much.
Thanks for the talk. Really fascinating stuff, and certainly not something I've ever thought about before. I'm sure it's the same for many people here. Just wondering, what was the response of parents and the children for the first time sort of being gathered together from schools and sort of put in a room to talk with a robot? And did that response change if there were repeat kind of assessments?
So when you say response, what do you exactly mean? Because the parents don't talk to the robot. Yeah. So in the lab setting, we have in our department, there's a mirrored room. So the parents are in the room behind sort of the glass, but because it's mirrored, they can see their child. And the child is, it's explained everything, and they're left with the robot, but they can call out, and if anything happens, we are just there, we can come in and so on. So when you say response, because they responded to the questions as well, but do you mean like overall sentiment of children?
Exactly, sentiment.
So children love robots. In fact, we have a board outside of the lab where they, left messages for now, afterwards, and so on, there was a movie made by the University of Cambridge for one of, I think Cambridge Imagines it was called last year. So for this particular project, there is a video, if you look on YouTube, you'll also find it. They filmed that part of the board as well, where kids left, or they did some drawing for the robot for now, or left messages and so on. Or statements and things like that. So in general, we haven't seen really children being apprehensive with child-sized robots. Obviously, if the robot is large, like an adult, could be scary, because even for adult people, I don't know if you've ever attended a robotics conference, but some of them can be like Terminator looking, so can be quite actually, can make you apprehensive. You might not go closer to them. But because it's not really threatening in any way, and this robot has been used for such research with children for 20 years now, so it's not just us, actually. It was created by Aldebaran, a company in France, and has been used by many labs across the globe for different research, but with children, including children with autism, which was not our focus.
Thank you. Yeah, fascinating just to get the wider context. Cheers.
Now, my question is about whether you know or you have conducted experiments where you have a human impersonating the robot. So controlling the robot and just talking, and whether this is ethical or it's just you don't do it because it wouldn't be scalable, but as a kind of a baseline to see, okay, is this working better than just having someone, a homunculus inside the robot just talking to the child or therapist? What's the difference, or is it because you want to do this autonomously in the future? Can you say a little bit more about this?
Sure, yeah. So in fact, for the online interactions, the robot was not fully autonomous because these children connect from countries where Wi-Fi is not great, so things might drop, or the communication, audio transmission might not be great. So it was actually wizarded, so to say. We call it wizard because the experimenter actually tries to control, to mitigate for such issues. So ethical aspects, we always get ethical approval anyhow, but we have done other research where we compared, not for children, also well-being, but it was mindfulness via robots, mindfulness coaching. We had actual mindfulness coach deliver in person as well as controlling the robot via certain interface we created with virtual reality. So they could see the robot through, like, they could see the room through robot's eyes, and if they look at their hand, they would see robot's hand and so on. We didn't see differences in terms of effectiveness of the delivery, but of course there were differences in terms of other aspects, like likability and so on. One benefit is, in fact, you know, even humans are biased. So when you go to a therapist, the research shows that even therapists might have biases depending on, you know, where the child or the adult person's background is from. If it's a black person, or, you know, like from other backgrounds, maybe it's not their native language, the way they speak. There are always biases present in humans as well. With robots, the good thing is actually some of these triggers can be eliminated, because maybe you don't like my hair because it's curly, or, you know, the way I'm talking might look different. But with a robot, none of these are magnified. You can eliminate a lot of these aspects, and you can make it repeatable the same way. Whereas with humans, maybe I drink coffee in the morning and I'm a bit sharper, but maybe in the afternoon, you know, there's not as consistency as you would do with a programmed robot. So there are different aspects and can be discussed in many ways. In any case, after the sessions, whoever we work with, adults or children, they always disclose what the whole thing, you know, has been about and so on. If there was wizarding, this is explained to them as well.
Well, thank you very much, Hatice.
Thank you.
Fantastic talk.